Hi everyone. In this given problem statement of word search, given an m cross n grid of character board and a string word, return true if the word exists in the grid. So basically, so one way of solving this problem is using a prefix tree or a tier node that can easily you can solve the problem. The other way could be using backtracking to solve it. So one thing for sure, we will have to use some DFS method out here. So the basic idea is that let's say we have formed this string, right? A, B, C, E, S, F, C, S, and we have to find the word A, B, C, C, E, D. So let us take this example out here. So let me create this one, which is having the character A, or let me take a smaller one, like second one, which is A, B, C, E, S, F, C, S, A, D, E, E. This is the idea. So one thing that we need to do, right? We need to traverse all the elements. So one way of doing it, right? So this would be a condition, right? So if I can say for, and first thing that we need to do, right? We need to find the length of the row. It is going to help for our bounding condition. So BOARD, and the column which would be length of, let's say, the first index. So BOARD of the 0. You can take any one for that matter. So I can say for I in range 0 to R, I going to traverse all the row, and for J in range 0 to C, and I'm going to call my DFS function, and I'm going to pass in the current I and J. In the DFS function, it would be translated to row and column index. So initial, right, if I'm at A, it would be 0, 0. And let me create something called visited. Visited would be a set value. So the first thing I'm going to check, right, is the bounding condition. So what are the bounding conditions in this one? So it would be like, if in case the current row is less than 0, or the current row is greater than equal to the capital row, or small c less than 0, or the current column is greater than the length of the column, or R and C, right, it's already in visited, or the current value, means the current value, right, if A, so I can say board of R and C. This is the first character, and we need to find the word C out here, right? So the first character of C is S. So if it's not equal to, and here I can pass in the index. So if it's not equal to word index, then I can say it's not correct, and I can say return false from here. And here, right, because it's going to start from here, so the current value of the word, right, would be 0. So it would be at this position. So it is not S, B, again it is going to traverse, right? So none of them would be, this would be S, but then if it would be S, right, then what I can do, I can say, and here, right, I have to create a substring. So if, or if before that, right, let me do few more things. So it would be substring. So here, right, it's not returned false. So that basically means, right, it is same. So I can say substring. Initially it is empty, right? So I will do plus equal to board of R and C. Now because it's already been traversed, right, I can increment it by 1 to see the next character. So I can say index plus equal to 1, and I will also add this one to visited dot add R and C. Correct. Now I have added it. Now what I can do, I can say result equal to, so I can call this DFS function, and I'm just not adding all the values. So it would be C plus 1, means it can go in 4 direction, right? It can go on top, it can go on the right, bottom and left. So C plus 1 and R, and again index and substring. I'm not writing it up, okay? So it can go in 4 direction. So DFS C minus 1 R, or DFS, I don't know why I'm writing C minus C plus 1, sorry. It would be R plus 1 C, R minus 1 C, R C plus 1, or DFS R C minus 1. So after that, right, if it's going into any direction, right, I can safely say, right, because if it's go on top, on left or right, right, none of them would match. So it is going to return false. Okay. So so that's why, because if any of one of them is going to match the next character E, right, it is going to return true. In this case, right, that's why you're going to write OR. In this case, it's going to return all the 4 directions, going to return false. So it is been, so I can say, right, it's S, even though we are able to find the S, right, but you're not able to find the next word. So it is also not correct. And once I've already traversed it, right, what I can do, because it's already been done and you're not able to find a value, right? So I can say visited dot remove the current R and C. Reason being, right, because if I hold it up, so the next time if you're able to find this word, right, so let's say if it's, for example, I can show it in this way. So let's say in case this was not S, right, so we need to remove it. Let us take this example. Okay, A, and we need to find high, for example. So A would not match. So in that case, or let's say in the, take us this example, A H I. A won't match, fine. I won't match, but I add the I to visit it, right? But when I'm the H, I need to find high. H matched, right? But if I go back, right, I can also match it with I, because I've already add these I to visited, right? It won't take it. So I need to remove I once I've already traversed it. So I need to remove it, and that's why I'm removing it. Then we go to F, C, none of them match. Once we come to S, right, A should match. So once A's match, right, we are again incrementing the index by 1. So and it is going to traverse on the top, left, bottom, and if I go to right, it's going to out of bound. But on the bottom right, we are able to find a word E, which E is going to match. So we find that word E, and now from this index E, right, I can again go on the left, right, bottom and up. Then I am again able to find another word which is going to match it up. Once it's got matched, right, so here I can add a statement which is if the current substring is equal to the word that we are trying to find, then I can say return true. So if it's returned true, that basically means you have found the word and it is correct, and the result would be true. And at last I can return the result. So that is the idea. Now let me, so we are able to find this word SEE, and we are able to returning true, and we are going to get the answer. The time complexity of this problem, right? It would be m cross n, where m is length and breadth of the matrix. Along with it, right, it would also be the length of the word that you are trying to find. So that would be the time complexity of it. If you're using prefix tree, maybe it would going to give a better solution, but it would be same. So maybe you can use prefix tree, right, in case if you have to find a list of words. So in that case, prefix tree would be more better to do, because if it's on one word, so it won't make much of a difference. That's all for this video. And now let us jump to the Python solution. The first thing that we need to do, right, we need to find the row length and column length. So it would be length of board, and the column, which would be length of board of 0. Once we have done that, right, we need to traverse it up. So for I in range 0 to R, and for j in range 0 to column, if DFS of I and j, and we have to pass in the empty string as we discussed, and the current word index. If that is true, then we can simply return true out here. Else we can say it is false, and we can return false if we're not able to find any matching string in this word dictionary or in this word matrix. We also need a visited to keep a track of the index which are visited, and it is going to be a set, so that we can retrieve it in big of one time complexity. So def, and let me call the function, it will take rnc and substring and the index. If r is less than 0 or r greater than equal to capital R, so we are checking for the bounding condition, or c less than 0 or c greater equal to capital C, or R and C in visited, or board of R and C not equal to word of index, then we can return false from here. Else I can say sub string plus equal to board of R and C and index plus equal to 1, means we are able to find a value which is matching, and it does not go to that escape condition, right? That basically means that it is able to find a value which got matched. So we are going to add that matched character to our substring, and we are going to look for the next character in that word. Now we can say if our substring is equal to the word that we are searching for, in that case I can say return true, and if not, then I'm going to add this to visited dot add the current row and column. Else I can say res equal to DFS r plus 1 c the substring and the current index, or it would be dfs r minus 1 column substring index, or because it can move into 4 different direction, right? So dfs r c plus 1 substring and index, or dfs r c minus 1 substring and index. And if still it's not able to find anything, right, I can say visited dot remove r and c, and I can return the result. So let me run the code. Unless there are any spelling errors, it should work. Yeah. Let me run it back again. As you could see, the public test case ran successfully, and let me submit the code. It ran successfully and is beating 41.89. If I run it like 2-3 times, it's going to give 64. And if you want to further optimize, you can use a prefix tree to solve it. That's all for this video. See you in the next one.